we are moving on to Unit 12. Unit 12 will be the hardest unit. We'll probably cover the whole year. We're building on what we've learned about graphing linear equations and solving linear equations, doing stuff in slope-intercept form, all that kind of stuff. We're building on all that, and now we're going to work with systems of linear equations. Unit 12 Part 1 is in your book. Part 2 and Part 3 are not in your textbook, so you'll really have to pay attention to the notes and check them for Part 2 and Part 3. But in Part 1, we are looking at solving systems of linear equations by graphing. So a system of linear equations is two or more linear equations with the same variables. So two more equations, but they have to have the same variable. The solution of a linear system is the ordered pair that is the solution of each equation in the system. So when we say ordered pair, we're talking about x, y coordinates. If you think about it, it makes sense because we're going to have two variables, so we'll have an x and a y. Before we get to actually solving by graphing, we're going to tell whether an ordered pair is a solution. So it says tell whether the ordered pair is a solution of the linear system. So for it to be a system, for it to be a solution of a system, it's got to work for both equations. So I have -2, -3, and I'm going to go ahead and plug it into the first equation. So that'll give me -3 equals 3 times -2 plus 3. So working that out, I'll get -6 plus 3, and then continuing, I'll get -3 equals -3. So that works. But I'm not done there. I have to do the second equation as well. So plugging into the second equation, be careful here, that's a -2 minus 5. Work that out, I get +2 minus 5, and I get -3 equals -3, so that works. So since both of these are check marks, then yes, this is a solution. I make sure you write that down. I'm going to erase it real quick. And let's look at the second one. Again, we're just testing to see if 2, 0 is a solution to the system. So I have to plug it into both equations. So starting with the first one, I'll have 3 times 0 minus 6 times 2 equals -12. 3 times 0 is 0. Minus 6 times 2 is 12. 0 minus 12 is -12. So that works. -12 equals -12. Now I need to plug it into the second equation. I replace y with 0. I replace x with 2. So I'll get 0 plus 12 equals 2, which is 12 equals 2, which is not a solution. So since this one does not work, the whole thing is not a solution. Alright, moving on. Let's look at solving a system of linear equations by graphing. So part 1 is going to be graphing, and then part 2 and part 3 will be two different ways to do this. So we've been doing a lot with graphing, so hopefully we have this under control. First thing we need to do is make sure each equation is in y equals mx plus b form. So for us, these are already on. So looking at the first equation, my slope is going to be 2. That's the 2 in front of the x. And my y-intercept is going to be 1, which is the one right there. For my second equation, my slope is going to be -1. Okay, we have the negative sign in front of the x, so there's technically a 1 there. And then my y-intercept is going to be 4. Now I have to graph both of these. Graph both of these on my coordinate terminal. So I'm going to graph the first one in blue. I go to the y-intercept, which is 1, and put a point. And then my slope is 2, which I can rewrite as 2 over 1 to help me with the rise and run. So I'm going to go up 2 and 1 to the right. And I can do that a couple times. Or I can go down 2 and 1 to the left. So I can go ahead and draw a line through those. Now I'm going to graph the second one in red. So I start at my y-intercept, which is 4. So go 1, 2, 3, 4. Put a point. Then my slope is -1, which I can write as -1 over 1 to help me with rise over run. So I'll go down 1 and 1 to the right. And I can do up and to the left if I want. So I go ahead and draw a line through that. And now, these aren't the most accurate lines. If you look, my lines cross at this point right here. Where the lines cross is my solution. And remember, it's going to be an ordered pair. So that's going to be at point 1, 3. So my solution is 1, 3, that ordered pair. Now, if you look at the backside, we're going to look at a couple special solutions. So I only did one example with the solution. Make sure you ask me if you have any questions. So for for the one on the back at the top, first thing we need to worry about is, are these equations in y equals mx plus b form? Which, if you look at them, both of them are not in. So first thing I need to do is put them in that form. So for the first equation, I'm going to add 6x to both sides. So I will get 3y equals 6x plus 6. Then I'm going to divide by 3. So I'll get y equals 2x plus 2. From there, I can label my slope as 2, my y-intercept as 2. If you don't understand how I did that, please make sure you ask me. I'm assuming that you know how to do that at this point. Then I also need to do the same thing for my second equation. It's 2y equals 4x minus 6. This one's a little bit easier because all I need to do is divide everything by 2. So I get y equals 2x minus 3. So I'll get a slope of 2 and a y-intercept of negative 3. Now, straight away, before we even graph, what I want you to notice, okay, is that these two equations have the same slope. They both have a slope of 2, but they have different y-intercepts. Okay, and as we graph, you'll understand why I had to write that down. So let's go ahead and graph. So the first one, I started my y-intercept, which is 2. So I'm going to put a point at 2. And then my slope is 2 over 1, so I'm going to go up 2 and 1 to the right. 2, 1 to the right, or I can go down 2 and 1 to the left. I'm going to go ahead and graph that line. For the second one, I'm going to start at my y-intercept, which is negative 3, so I go down 1, 2, 3, put a point. Then from there, I'm going to use my slope, which is 2 over 1, so up 2, 1 to the right. Or I can go down 2 and 1 to the left. So if you look, these two lines are never going to touch, okay, because they have the same slope and different y-intercepts. So we say that these lines are parallel. Okay, parallel lines mean they're never going to touch. Our answer would then be no solution. So if you remember back when we solved equations, it was possible to get no solution. This is how you get no solution when you're doing a system. You have parallel lines. All right. Looking at the last one, again, these equations are not in y equals mx plus b form to start. So that's the first thing we need to do. So for the first one, I need to move this x over to the other side. And then divide everything by 2. So I'm going to wind up with y equals 1/2 x plus 2. So my slope is 1/2. My y-intercept is 2. Again, if you have any trouble with that, let me know. I'm assuming you know how to do that. For the second one, I have 6y minus 12 equals 3x. And to add 12 to both sides, 6y equals 3x plus 12. And I can divide everything by 6. So y equals 3 over 6x plus 2. And I'm going to simplify 3 over 6 to 1/2 x. So my slope is 1/2. My y-intercept is 2. Now, what I want you to notice about these two is that they have the same slope and they have the same y-intercept. So when I go to graph these, for the first one, I'm going to go up 2 and put a point. And use my slope, which is up 1 over 2. Or I can go down 1 and 2 to the left. So that's the first one. Now when I go to graph the second one, I'm going to start my y-intercept, which is also 2, and use my slope, which is 1 over 2, or down 1 to the left. So if you notice, these are the exact same line. Okay, they have the same slope, same y-intercept, which makes them the same line. Which means when we say that they have infinitely many solutions. So that's what you'd have to write for your answer. Now, if you think about it, it makes sense. The solution is where the lines cross. If they're the exact same line, they're crossing all the time. All right, make sure you ask any questions you have on that, especially since I only did one example of each.